Hello everyone. Is I audible to all of you? Hello. Okay. Hello everyone. I am Dr. Sunil Kumar Srivastava, and today we are going to discuss our lecture number 10. The topic is the measure of dispersion. That is the total statistics portions. And here we have our previous lecture. We have discussed about the some statistical terminology like that. The mean. What is the meaning of the mean? What is the bar graph? And what is the how the data can be represented? What is the data types and other things related to this one. Now we have to extend this lecture in the terms of the other statistical measures, that is measure of central tendency form. And before going to start the session, we have to come across some general guidelines that we have to follow during our learning lessons. First of all, we have to maintain the discipline for a smooth conduction of the interactive live sessions. For the attendance purpose, you have to type your name, enrollment number, and program name in the chat box to mark your attendance here. You have to raise your questions after only completion of the sessions and do not interrupt between the sessions. You have to avoid posting any irrelevant questions and do not start any personal conversations. Interaction with the faculty should be the constructive. A no disruptive comment is appreciated. If you feel any issues, you can contact on the given academic support services, or you may also contact, post your queries to the IMS managers _CDOE@bgu.ac.in. So this is the guidelines. We have to always follow this one. Before going to start the session, we have to know what is the learning outcome of these sessions. What will be learned after completion of the session? This is the learning objectives. The topic name is the measure of dispersion. So first, we have to learn what is the concept of measure of dispersion. First, we will have to learn what is the measure of dispersions. Also, we have to analyze the central tendency of the data sets by the measure of dispersions. You will be also able to understand the concept of correlations and regression analysis form. That's it. So these are the terminology which have to some key points that is the comes in the terms of our learning objectives after the completion of the sessions. We have to learn here. Now we have to start the sessions with our introduction portion. What is the meaning of dispersions? What is the meaning of dispersion? So before going to start the session, this is statistical data. Dispersion is the data, is the measure of spreading or the data about the central tendency. Because we have to know in our previous lectures, we have discussed about the measure of central tendency that we have discussed with you. Mean, median, and mode. This type of data will distribute the data around a in systematic orders. So the dispersions of the data is the measure of spreading the data about the central tendency. Dispersion helps in the distribution of the data. The measure of central tendency are not sufficient to give complete interpretation of the given data. So variability is another parameter to include it in the study of statistics. Like the measure of central tendency, we have to know and we have to need a single number to describe the variability. The single number is known as the measure of dispersions. So these are the some key points about the measure of dispersion. Actually, it's a difference. It is not include anything, but it's to describe and it could denote the dispersions that is spreading of the data about the central tendency form. That is about the mean. It can be about the median. It can be about the mode also. So this single tendency will describe the forms of variability, and that is known as the measure of dispersions. So this is the points, and we are going to start our sessions in the terms of related to this terminology. Before going to read the measure of dispersion, we have to know some key points related to describe this one in very systematic orders. In statistics, measure of dispersion helps us always understand the variability of the data. That is, know how much homogeneous or heterogeneous data is given. In other words, it shows how squeezed or scattered the variable is. So dispersion is the measure in the following types. It can be measured in the types of range, It can be measured in terms of the quartile deviations. It can be measured in the terms of mean deviations. It can be measured in the standard deviations, and it can be measured in the terms of variance. So these are the terminology, and one by one we have to read in this our lectures. One by one we have to go read this one in this our lectures. So first of all, we have to start some terminology. We have to range. What is the meaning of the quartile deviation? What is the meaning of its mean deviation? What is the meaning of its standard deviation? What is the meaning of its variance also? This is the terminology, and we have to read this one. Now moving further, we have to know what is the meaning of range. Always its name defines we have to range. Range means what is the difference of the maximum and minimum value of the given data set. So range is defined. Range is the difference of maximum and minimum value of the data. If we have any data set is given, its maximum value and its minimum value we have to point out, and difference of that will be known as the range. So formula is here, range is equal to maximum value minus of minimum value. This is the range. Range is equal to maximum value minus of minimum value. That is here meaning. For example, we have taken example is here. Consider the marks of is obtained by a student in a sessional examinations are. We obtain the marks 39, 33, 45, 19, 41, 21, 19, 21, 41, and 40. So here if you see this data in very clear way, we have the get here the highest marks obtained by the student is here 45. 45 is the highest marks. This the maximum marks is here 45. Okay. And now we have to see what is the minimum marks. Minimum marks is obtained by the student is here. That is 19 is here. That is the 19 is here. The minimum marks is also. 19 is the minimum marks of the student. So difference of this one is denoted as the range. That range is equal to maximum value 45 minus our minimum value, that is the 19, and it is equal to of the 20 of 6. So range is always defined by maximum value minus of minimum value. That is the difference of this one. So we have to read the data. We have to see the data in very clear way, and we have to know what is the maximum value of the given data sets and what is the minimum value of the given data sets, and the range will be defined as the maximum value minus of minimum value. Suppose we have another data set of the form 39, 46, 29, 38, 50, 858, 27, 36, 39, 17, 16, 15, like 37, 27, 54. Then in that case, what will the range of this one? So we have to just see what is it's a maximum value. What is this maximum value is here? We see this one, the maximum value obtained is at 58. That is the 58. So 58 is maximum value minus a minimum value here obtained, that is the 15. So minimum value is 15. So difference of this one will be the range of the given data set. So what is the conclusion? The range of the data set gives us a rough idea of the variability or scatter where does not tell about the dispersion of the data from the central tendency. It also gives the rough idea, not the exact dispersion of the data set about the central tendency. So by saying this one, we can find out the range about any systematic idea. We can analyze the data should be the lie between these two, this interval forms. Now moving further, we have to know what is the meaning of quartile. Second terminology here, that is the quartile. That is the quartile. What is the meaning of the quartiles? Quartiles are values that divide a list of number into quarters. Quartiles are the values that divide a list of the numbers into the quarters. The quartile deviation is half the distance between the third of the first quartile The quartile deviation is the half of the distance between the third and the first quartile. A quartile divides the set of observation into four equal parts. Four equal parts. That is the first quartile, second quartile, third quartile, and the fourth quartile. The middle term between the median and the first term. The middle terms between the median and the first term is known as the lower quartile and denoted by the Q1. That is denoted by the Q1. That is the median. That is the median and the first term. That is the first term. Suppose the middle this one. The data between this one. The middle term between the median and the first term is known as the first or lower quartile, and that denoted by the Q1. Similarly, the value of the midterm that lie between the last term and the median. Value of the lie between the last term and the median, that is known as the third or upper quartile. That is noted by the Q3. So we have understood clearly what is the meaning of the Q1, what is the meaning of Q3. Q3 is the midterm that lies between the last terms and the median, and Q1 is the middle term lies between the median and the first terms. That is the lower quartile and the upper quartile, and denoted by the Q3. Second quartile is the median. Second quartile is the median denoted by the Q2, denoted by the Q2. So therefore, when all the set of observation is arranged in the ascending order, when all the sets of observation is in the ascending order, then 25th percentile is given by Q1, and that is given by n plus 1 by 4th term of the given observation. What is the meaning of the Q1? We have to arrange the data in ascending orders, and then 25th percentile of the given is given by n plus 1 by 4th term of the given observations. N plus 1 by 4th term of the given observation. And that the values give us the value of the quartile Q1. What is the Q1? Q1 is the middle term that lie between the median and the first term. That lie between the median and the first term. Now, moving further. To define second quartile. To define here second quartile. Now, the second quartile that is denoted 50th percentile of median, that gives us Q2, and that is denoted by our observation n plus 1 by 2th term of the observation, n by 2th term of the given observations. What is the meaning of the Q2? Third quartile is denoted by the 75th percentile is given by here. That is the Q3, and denoted by 3n plus 1 by 2th term of the given observations. 3 minutes. Q3 is nothing but that is the 4 times of this one. Q3 by 2, that is the n plus 1th term by of the given observations. So therefore, upper quartile is given by the rounding the nearest whole integer of its solutions coming in the decimal numbers. The major use of the lower and the upper quartile help us to measure the dispersion in the set of the given data. Therefore, dispersion is also known as the interquartile range. That is known as the interquartile range. That is known as short form is the IQR. Interquartile range. That is noted by interquartile range. IQR. Interquartile range is the difference between lower and upper quartile. Lower and upper quartile. Lower quartile is your Q1, upper quartile is your Q3. And the difference is that Q3 minus Q1 is denoted by interquartile range, IQR. Interquartile range, that is denoted by IQR. interquartile range. Okay. So this will help us to describe the data sets in the more cumulative form to describe the analysis the data scatteration of the data about the central tendency form. So that is the IQR upper quartile minus of lower quartiles. So we have given all the definitions of Q1. That is the definition of the n plus 1th by 4th term of the given observation. Q2, that is the n plus 1 by 2th term of the given observation, that is the 55th percentile of the given variance. And third quartile, that is the Q3, that is noted by 3n plus 1 by 2th observation of the given observation when the data sets are in the ascending orders of the given sets. Now, so these are some terminology about the quartile. Now we move to the other concept, that is the mean here. What is the meaning of mean? So already we discussed with you mean, and now we are going to discuss the mean deviation, mean deviations. In our previous lecture, we discussed the mean, what is the definition of mean, how to calculate by the direct method, or how to calculate step deviation methods, and how assumption method to describe an analysis of this one. So here we are going to discuss about the deviations only. So mean deviation is denoted by the term that is known as mean deviation denoted by the term that is the mean deviations. So mean deviation is the arithmetic mean of the absolute deviation of all values taken about any central values. Any central value about the mean line and denoted by the mean deviations. The following methods you help us to find the mean deviation for the group of the data sets. And we already know that there are two types of data set groups and group data. One is the ungroup, another is the group data. So how we calculate the mean deviation for the ungroup data and how we calculate the mean deviation for the group data. So first we discuss here mean deviation from the mean of ungrouped data or ungrouped data. To find the mean deviation, we have to take sum of deviation from the central tendency. If central tendency is taken as the mean, the deviation taken will be taken from the mean also. Okay. Suppose we have the data. So we have to first calculate its mean x bar. And then we have to calculate the difference of this one, x minus x bar for all this one. So that is denoted the deviation. So therefore, to find the mean deviations, we have to take sum of the deviation from the central tendency. Some values are greater and others are smaller than the central tendency. Therefore, some of the deviation will be the negative and some deviations would be the positive. Thus, sum of the deviation may be 0. Sum of the deviation may be 0. Not exactly, it may be 0. So mean deviation will be 0 upon number of observation is equal to 0. So mean deviation will be 0 upon number of observations. This formula can be used to find out, and the same sequence to working rule to find the mean deviation from group data from the mean. We have to go through that with some systematic orders. First of all, for step number 1, we have to find the mean of the given data sets. What is the mean formula? That we have to sum of the all observations, sum of f of x upon sum of n. That is. So we have to take the sum of all observation and total number of observations divided by, you can get the mean of the given data set of the ungrouped data set. Meaning is that, suppose we have a data set 3, 4, 6, 9, and 10. So first of all, we have to find its mean. We have to add all the data 3 plus 4 plus 6 plus 7 plus 8, and that is divided by the 5. Okay. So 4 plus 3 is 7, 7 plus 6 plus 4 10, or 10 plus 3 13, 13 plus 7 18, 13 plus 7 20, 20 plus 8 20, 28. Suppose you take it 10, okay, 10, that 30, 30 divided by 5, that is becomes equal to the 6. So that is meaning the 6 here. So first of all, you have to take this one. Second step, we have to take the division of each observation. Suppose this is the 3, this is the 4, this is the 6, this is the 7, this is the 8. This is the xi. Okay. Now we have to take the division of each observation xi. That is the xi minus of x bar. We have to take the division of this from this mean 3 minus 6. That is that 3 minus of 6 is equal to minus of 3. Here 4 minus 6 is equal to minus of 2. Here 6 minus 6 is equal to 0. 7 minus 6 is equal to here 1. And 8 minus 6 is equal to here 4. So we find out. We have to sum. We have to do minus 3 minus 2, that is the minus 5, plus 4 plus 1, 5, that is equal to here 0. It may be 0 or not. Just I have explained in our previous PPT. We have given also mentioned here. We have also mentioned here. Some of the deviations will be negative. Some of the deviation will be the negative and some may be positive. Okay. So we have find out, and some of the deviation may be 0. Sum of the deviation, not sum. This is the sum of deviation. SUM is here. Here is SOME, sum. So sum of all deviation must be maybe 0, not exactly, but maybe 0. So here we have taken an example to describe with you. That is the first one and 2. But sum of all the deviation may be 0. Here find is 0. That is a 0. So some deviation may be also be 0. So we can find out the second step in this way. Then find an absolute value. X bar minus of x by. Now all should be the given the positive. Then find the sum of division of all this one and divide the sum by the total number of observation 1 by n sum of x bar I minus x bar and I is equal to 1 to infinite, and you can get the mean division of the given data set. So this is the formula. This will be used to find out the mean division for the ungrouped data set. This formula can be used to find out the result for ungrouped data set. So this is the formula. Now, how to use and how to calculate the mean deviation of the mean for the group data. Just we have discussed with you how to calculate the mean deviation for the ungrouped data. Now we are going to discuss with you how to calculate the mean deviation from the mean for the group data. Okay. So how to calculate the group data? Suppose we have given the observation x1, x2, xn are the observation, and for the corresponding frequency are given as f1, f2, fn. Suppose for x1, and this is the x and this is the frequency. This is the 3, this is the 4, this is the 6, this is the 7, this is the 3, this is the 9, this is the 6, this is the 7. Sorry, this is the 8, this is the 7, this is the 9, this is the 2. So this type of frequency. Suppose we have a given number of observation x1 to xn, x1, x2, x3, and so on xn. And for all the given corresponding frequency are given as f1, f2, and fn respectively, then the mean division will be given as in the form mean division is equal to 1 by n. 1 by n means 1 means total frequency. Total frequency means sum of the all frequency, that is equal to f1 plus of f2 plus of f3 up to the f of fn. This is the sum of all the frequencies, okay, respectively. Then the mean division may be given in the form Now, what is the meaning? And that is the summation of frequency distribution from its mean. That is that we have to take the absolute value of the deviation and it should be the multiplied with the frequency. And then we have to take the sum. So this is the formula we use to find out how to calculate the mean deviation from the mean for the group data. We have the given the problems. We have to use the things to describe and find the answer for our particular purpose of use. So we have to discuss what is the working rule. If you understood the formula in very clear way, we have no need to learn the step to describe. The formula is written here. That is written 1 by n. And summation of I is equal to, sorry, n is equal to 1 to n. Summation of fi, an absolute value of xi minus of x bar. So we have to need this step. First of all, we have to calculate its mean value. Then second step, we have to take its deviations. Third step, you have to take the absolute deviation, absolute values of the deviations. Then fourth step, you have to multiply this with the frequency. And fifth step, you have to take the sum of all this one. And sixth step, you have to divide the sum with by the total number of observations. This is the step. And we have written the sixth step in 1 by 1 here. So first of all, what I have to do? For the mean of the observation using the formula, with this is known as the direct method. This method is known as the direct method. Direct method. This formula is known as the direct method. Sum of all the frequencies upon total number of frequencies. You can also use the other methods to find out the mean of the given data, say like step deviation method, assume the mean method, and so on. So you can use this one, but simple and sweet method is here, direct method, and that is a very easy to use. So I suggest you, when we're going to find out the mean of the given data set, we have to use the direct method to describe your answer in very clear way and without errors. Now we have to use the second step. After finding the mean, we have to find its deviation from each observation. That is for each values of x. For x is equal to x1, x2, and so on. Suppose you take the examples right like 3, 4, 6, and 9. This is the value of here xi. And this is the value of here fi. That is the 4, 6, 7, and 8. So first we have to what to do? That we have to find its mean value. What have to do? 3 into 4. That is the 12. 4 into 6, that is the 24. 6 into 7, that is the 42. 9 into 8, 72. We have to take the sum and divide by the total number of frequencies. That is the 4 plus 6 plus 7 plus 8. That is. So we have to add 2 plus 4, 6. 6 plus 2, 8. 8 plus 2, 2, 10. And 1 plus 2, 3. 3 plus 4, 7. 7 plus 7, 14. 14 plus 1, 15. And divide by here 4 plus 6, 10. 10 plus 8, 18, 18 plus 7, that is the 25, divided by 25. So mean is here getting by 6 years. So mean is 6. Now its first step will be clear. Now we have to take the second step. We have to take the division from each of the values. So we have to take the division xi, 3 minus of 6, 4 minus of 6, 7 minus of 6 minus 6, 9 minus of 6. And I have to take the second step. Third step, we have to find out the absolute value of this observation. We have to find out the absolute value of these observations, xi minus of x bar. And fourth step, we have to use fi xi y minus x bar. This is our fourth step. And finally, fifth step, find the sum of these observations. We have to find the sum of these observations. Fi xi minus of x bar, fi is equal to 1 to n is equal to 1 to n. And divide the sum by the total number of observation, you get the mean deviation. You can get the mean deviation for the group data set. So this is the formula and that we have to use to find out our problems. Now we have taken some problems to describe our method to this in detail with you. And we have the first problem is that for our ungrouped data, that problem is based on the ungrouped data. That is the ungrouped data. Ungrouped data. That is the problem. So here written is here, find the mean deviation for the from the mean of the following data set. And the data set is a 38, 70, 48, 40, 42, 55, 50, 63, 46, 55, 44. And we have to start our solutions. The given data form is ungrouped because it is in randomly order. Now we have to proceed the following step. First of all, we have to take the mean of the observation. We have to take the mean observation. Formula is written by sum of all the data, sum of all the observation upon total number of observations. So total observation is here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The total observation is 10. And sum of the observation, we have to 8, 38 plus 70 plus 48 plus 14 plus 42 plus 55 plus of 63 plus of 46 plus of 54 plus of 44. And we find their sum is 500 and total observation is at 10. So mean is 50. So first of all, we have calculated mean is here 50. The first step is almost clear to all of you. We have to find the first step. We have to find the mean. Okay. Now we proceed to the second step. We have to take the deviation from the mean. We have to take the deviation x bar minus here. So all we have to all the data should be here, and we have the mean is at 50. So in the next step, we have to prepare a table for the observation purpose. We have taken the observation here. That is a given xi. This is all the values of x. 38, 70, 48, 40, and 42, 55, 63, 46, 50. These are the values of this one. And just in our previous step, you find out the x, but that is the mean is at 50. So the next step, we have to find the deviation the xi by minus of x bar. So we have to take the deviation from the mean. We have to take the difference 38 minus 50. Here the 38 minus of 50, that is equal to minus of 12. 70 minus of 50, that answer is here 20. 48 minus of 50, that answer is here minus of 2. 40 minus 50, the answer is here minus of 10. 42 minus 50's answer is here minus of 8. 55 minus 50's answer is here 5. 63 minus 50's answer is here 13. 46 minus 50, his answer is a minus of 4. 54 minus 50's answer is a 4. And 44 minus 50's answer is a minus of 6. This is known as the deviation from the mean table. And the next step, we also prepare a table in which you can take the absolute value. Absolute values, all the values taken should be the positive, not negative, all the positive. So we mention here, we have the minus 12, it becomes 12. 20 is also already 20. Minus 2 becomes the plus 20. Minus 10 becomes the plus 10. Here minus 8 becomes the plus 8. Plus 5 is also plus 5. 13 is taken to 13. Minus 4 is taken to the plus 4. Plus 4 is taken to the plus 4. Minus 6 adds to be the 6. Plus 6. And we have to take the sum of all these observations. That is total sum is 684. That is denoted by the sum of all the observation of absolute values. That's it here. And that is answer is 84. So we have to proceed for the second step. In the second step, we have to proceed. Instead, we have to take the deviations and find out its absolute value sum. Now we proceed for the second step, third step. The sum of absolute value is the derivation of the obtained by and is equal to the 84 is here. Now for the second step 4, we have the mean deviation, and mean deviation formula is given by here 1 by n. 1 by n means n is that upper number of observations, that is equal to here 10 observation as here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 84 by 10 is equal to the 8.4. So mean deviation is here 8.4. That is the mean deviation is 8.4 is here. So mean deviation is here 8.4. Okay. So I think you understood the concept of how to calculate the mean deviation for the ungrouped data. Now we take another example to describe with you. Okay, no, observation is here. Now we move further to describe the other things. Deviation from the median. Mean deviation from the median, and that follows the ungrouped data also. We are going to discuss mean deviation from the median is also. We have the median of three centered tendency, that is the mean, median, and mode. So mean deviation can be taken out from any of the centered tendency. Okay, the mean deviation should be the from the mean, mean from the mode, mean from the median, mean deviation from any arbitrary number also can be defined. So before going to start the fun group data, we have to know what is the concept of median and how to find out the median of this one. So first of all, we have to calculate the median. So median for the ungrouped data, we have the two formulas here. This depends upon the total number of observation in the given table. What I have to do, suppose we have taken an example here. Suppose I am writing here 3, 4, 5, 6, 7, 8 here. So this is answer have the 9. This is total number of is 9, and 9 is the odd number. So if the number of observation are odd, then median term with the observation is n plus nth by 2 term. Suppose the ninth term of here, so first of all, we have to write the given data in ascending or descending order, first of all. So here we have already written here data in the ascending order. So total number of observation is at 9. So 9 plus 1 by 2, th term, that is the 10 by 2, that is equal to fifth term of the given observation. So first, second, third, fourth, and fifth. So this value will be known as the mean deviation of the mean and the median of the given observations. Now, if the number of observations are even, if the number of observations are even, the median will be the arithmetic mean by the n by 2th term, n by 2th term by observation of the given frequency. Meaning is that n is here 5. Suppose taken the number of observation is equal to 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, and 7. So total data set is here 7. So number of observation is 7 plus 1 by 2 terms. I'll some mistake here. 10. So number of terms is 7. Okay. So 7 plus 1 by 2, that is the fourth term will be the median. Meaning 6 will be the median of this observation. But in the case is the number of observation is even number. Suppose 9 plus 1 is also given a number is 10 is also here. So observation is 1, 2, 3, 4, 5, 6, 7, 8 is here. So there are two midterm, that is the fourth and fifth, and we'll take the mean of this one. The fourth term is here 6, seventh term, fifth term is here 7th. We will take the sum 13 divided by 2, that is equal to 6.5. That will be the median of the given observation when the observation is in the terms of even number of terms. So if the number of observations are even, the median is the arithmetic mean of the n by 2th term and n by 2 plus 1th observation of the given data sets. In that case, median of the given set observation defined as 1 by n, deviation from absolute deviation from a median, not mean. Absolute deviation from its median. So I think you understood the concept. Before going to write the answer of any problems, you have to first clear the concept. What we have been asked with you. What is going to be asked with you? Division from the mean, division from the mode, division from its median. First of all, we have to calculate that things. Okay. Now, for the group data sets, same concept for the group data sets. But for the group data sets, we have to for each and every value of the given data. So next one has the frequency is F1, X2 have the frequency F2, and so on. In that case, mean deviation of the given data set is given as the formula. That is 1 by n total sum of the observation, mean deviation, absolute deviation, and the multiplied by this frequency. So how to calculate this median for the group data set? Median formula given n L plus n by 2 minus CF upon F into H. And that formula already you know. And when I told you that so about the concept of median, how to calculate the median, and that stopping formula was given there. And now we can use this formula to find out the first of all mean, median, and then each and every concept is written in the tables. First of all, we have to calculate the median, first step. Then take the difference of them from the median. So we have to define the deviations from medians. Then take the absolute deviation from the medians. Then multiplied with the frequencies. and then find that sum and then divide the total number of observation. So this is the step one by one you have to calculate, find out, step forwards to calculate your answer. And formula is given by the median is that is L plus n by 2 minus of CF. CF is cumulative frequency, not the CF, that is the cumulative frequency. Cumulative frequency. That is the cumulative frequency. So now moving further, next step, we have to know the standard deviations. That's the most topic is that's come here. That is standard deviation. Now, standard deviation. What is the main standard deviation that is noted by short form that is S2, that is standard deviations. So we have to know the definition of that first. Standard deviation is the deviation of the values or observation from its the mean. Standard deviation that is noted by the sigma, that is noted by the sigma. It is noted as sigma. SIGMA, that is noted by sigma. It is read by sigma. It's right like inverse of 6. Okay, you can write the like that sigma. So denoted by the sigma. Lower standard deviation conclude the values are very close to the average, and higher standard deviation means the values are very away from its mean values. The standard deviation is always positive values. So therefore, standard deviation have always the positive value. So lower the standard deviations. Conclude what is the meaning to represent. Suppose standard deviation value is the very much 3.3 and what is the value of 9.9. What is the meaning of that? It's hard to conclude from the observations, how to read the data, and this data what information get. So we have to know also its numerical values, how to its values going to be defined. So lower standard deviation conclude the values are very close to the average, very close to the average, and higher standard value give the values are very far away from its mean value. The absolute value are considered in evaluating the mean deviation from it, the mean. It is the negative and positive deviation may cancel among the cell. To overcome this difficulty of the sign of deviation, we take the square of all the deviations. To overcome the difficulty of the sign of deviation, we take the square of all the deviations. So it becomes negative, becomes always become the positive and so on. So we take the observation of this one. Now, suppose we have the values x1, x2, xn. We have an observation and its mean is given by x bar. So x1 minus x bar is square, x2 minus x bar is square. That is summation of the mean deviation is square, xi minus of x bar and square values. So it's become all values becomes the positive. If the sum is 0, the division has also to be the 0. It means there is no dispersions at all, as all observations are equal to the mean value. If the sum of observations, if the sum of the square of the division is small, that is, if the sum of the square of the division is small, that indicates that observations are very close to the mean, very close to the mean. Therefore, the degree of dispersion is small. If the sum is larger, it shows there is high degree of dispersion. There is high degree of dispersions. So standard deviation for an individual series for the formula is given in the terms of this one. Sigma, it is equal to square root of this one, 1 by n, summation of all the data set of the square values of deviation xi minus of x bar square. And this formula can be used to find out the standard deviation of the given data set. So we find here if the sum of the square of division is small, observation are very close to the mean, and if the sum is very, very large, then there is high degree of dispersions. There is high degree of dispersions. So by the values, you can get the meaning. What the answer you say, what answer indicates. It can conclude by the statistical data, and information should be the can be used for the further investigation purpose. So our next article, that is why is the variance also. What is the variance? Variance is the measure how notably collection of data is scattered. If all the data values are identical, then it indicates the variance is zero, symmetrically distributed. If all non-zero variants are considered to be the positive, a small value of variance, this represent the data points are very close to the mean and to each other. Whereas if the data points are highly scattered from the mean, then one of the another indicates high variance also. So therefore, variance is defined as the average of the squared distance from each point to the mean. That is the xi minus x bar whole square, sum of I is equal to 1 to n, 1 by n, that is the square values. So variance is the square of this one. The variance is denoted by the sigma square, standard square. Sigma square is the set of the data defined as the square of the standard deviation. Square of the standard deviations. So the variance of the individual observations, suppose we have the individual x1, x2, xn, and so on, for n observations. So variance is given by the formula 1 by n, summation of I is equal to 1 to n, division of square of all, and xi minus x bar whole square. That is the divisions. And for the group data set, suppose the variance and division are taken from a assumed means, taken from the assumed mean. So 1 by n, summation of I is equal to 1 to infinite xi minus x bar square minus a mean square. Minus of mean square. That is the formula when taken about a assumed mean. We are going to use the assumed mean method is here. So these are the formula that are going to use. What is the working procedure? That is the working procedure. What is the meaning of working rules? What to calculate the things about the when the assumed mean method. First of all, we have to select an assumed mean from the given data set. Suppose mean is A. We can take the observation and from the given set range, and from that set you can define, you can take any values as the average of mean. So a assumed mean can be taken without any calculations, and that is denoted by the capital letter of A. The assumed mean is calculated. Then step number 2, take the division of the observation from the assumed mean. Then you take the division from the assumed mean. So here division denoted by di, and the division xi minus of e. That is the assumed mean. In the third step, we have to take the sum of all the divisions. In the fourth step, find the sum of the square of all the division. That is the summation of I di minus this one. Summation of I is equal to 1 to n xi minus of x a bar, that is the whole square. We have to take from this all this sum. And finally, we put the values in the given formula, that is the 1 by n summation of division square minus 1 by 1. That formula gives the mean values. Okay. So d by n, that is the mean square. This formula gives the mean square. So these values we obtained by the formula written above. So we have come across the learning outcomes of the sessions here. Finally, we come across here learning in the terms of learning outcomes. Finally, the topic was here measure of dispersions. In this session, with the live interaction with you, we have discussed within details the various topics that is denoted the measure of dispersions. So first of all, we have cleared the concept with you. What is the concept of measure of dispersions? What is the meaning? Why you are going to read this one? And how this data should be useful to describe the analysis of given data sets. And to read the data set, we have the read the some basic terminology like range, quartiles, standard deviations, mean deviations, and the variance related terminology to describe the data set in very conceptual way to analyze, and concept should be the enhance your knowledge to describe the data. And finally, we have analyzed the central tendency of data set by the measure of dispersion concept. And we have also given the concept of correlation. Correlation means we have going to be the variables are related to each other. When suppose one variable is here, suppose we have one variable is here demand, one variable is here demand, and other variable is supply. Other variable is supply. So these two variables, suppose this variable X and this variable Y, these two variables are related to each other. But in fact, when demand is very, very high, when demand is very, very high, and then supply should be the more acceptable. Supply should be the high rate. Yeah, suppose we are take the other variable like as a price, not take the supply, we take the other variable as a price. So demand will be the high, price will also increase. That will also be the demand. And the demand will be very, very low, and that price will also going to be decrease. Meaning is that price depends upon the demand. If demand is high, price is also high. Demand is very, very low, price is also. These two variables are connected to each other. So we can say that there is a relation between these two variables. And that relation is known as the correlations. And that relation is known as the correlations. And how much correlation, how much they are correlated to each other. Now, what is the maximum effect? How to effect can be calculated mathematically? That will be read in the concept of regressions. That the concept in the concept of regressions. So we have also some concept about this one. Any doubt from your side today our learnings? You can raise your questions in the chat box. Happy learning to all of you. Any doubt from your sides? You may raise your questions to here. Interested to write the questions. You may ask the questions. Okay, I think all of you had the Cronus concept clear. So now I want to say you that our this was our 10th lectures, and only 2 lectures are remaining for our completion of the session. So all of you take the all the learn the all the see our videos and all the see the PPTs to make the best preparation of your upcoming examinations. And almost 80% syllabus is have to done. Only 2 PPTs are remaining here. And next pick upcoming next 2 slots it can be also done. So best of luck to all of you to enjoy the journey enjoying the sessions, and good luck to all of you and read the concept. Thank you very much for joining the session.